Let's build a complete REST API performing all CRUD operations. In this tutorial, I will guide you step by step from creating your data entity and setting up a Spring Data JPA repository for all database interactions to implementing a robust service layer. We will then build a complete REST controller covering every essential CRUD operations, creating new products, fetching them all or by specific criteria like ID or category, updating existing ones, and finally deleting them. You will see comprehensive testing with Postman for each endpoint, ensuring you have a fully functional API by the end. Let's get started. I will start the project from scratch. For this, I am going to use my favorite Spring Initializer tool. Go to start.spring.io. From here, select Maven as the project. The language is Java, and for the Spring Boot, at the time of this recording, the latest Spring Boot version is 3.4.5. Select this. Then provide the metadata. For the group name, it is just simply your domain name in reverse order. Mine is com.learn_with_iftikhar. Then provide the artifact, that is Spring Boot REST API. Then provide a small description. Spring Boot REST API development. Then packaging is jar, and for Java version, my installed Java version is Java 21, so I am going to use this. For Spring Boot 3 and up, you need to use Java version that is 17 or up. Now it's time to add the necessary dependencies. Click this Add Dependencies button. From this model window here, we can search for the dependency. The first dependency we need, that is Spring Web. Then we are going to store the data in the database. So for this, we need to include Spring Data JPA. And also, as we are going to use MySQL as database, so we need to include MySQL database driver. Search for MySQL driver. Include it. So that's all the dependency that we need for now. If we need any dependency in the future, we will add that manually. Now click on this Generate button to generate the project. Our project is generated and download as zip file. Extract this file and open this in your favorite IDE. Here I have opened the project in IntelliJ IDEA. I am using IntelliJ IDEA Ultimate Edition. If you are using any other IDE like Eclipse or Spring Tool Suite, go with that. IntelliJ IDEA also have a community edition which is completely free. You can also use that. Or if you want to give Ultimate Edition a try, then check the description of my video. I have provided a coupon. With that, you can use this IntelliJ IDEA Ultimate Edition 3 months completely free. Now, our project is opened. Here, you can see in the left sidebar the files and folders of our Spring Boot project. Let me give you a short summary of the project files and folders. The first file I'm going to show you is pom.xml. This POM stands for Project Object Model. This holds necessary information about our Spring Boot project. Here you can see at the top we have this group ID that we have defined earlier while creating the project. Here we also have this artifact ID, then the name of our project, and also the short description that we have provided earlier. If you scroll down, here you can see that we have these properties. Here the Java version that we are going to use is defined. And below we have this section for dependencies. These dependency sections hold all the dependencies that we have defined. If we need to add any additional dependency, we need to provide in this dependencies tag. Here this is dependency for Spring Data JPA. This one is for Spring Boot Starter Web. Then we have this MySQL connector dependency, and we also have this dependency for testing. This is the main part of our pom.xml. Let's check other files and folders. Here you can see we have this src. In this src folder holds all the source code of the project. Expand this. Here we have these two subdirectories, main and test. All the test code we write will go there. Then we have this main directory. Expand this. This main directory further consists two subdirectories, Java and resources. This resources directory holds another two subdirectories, static and template, along with a file, application.properties. This application.properties file holds the necessary settings of the Spring Boot project. Here we can provide the settings like database credentials or server information. Then we have this template directory. This template directory holds the HTML files. Then the static directory, all the static resources like JavaScript, image, and any other static resources will be kept there. Let's collapse these resources. Then we have this Java directory. Let's check this Java directory. This Java directory contains our base package, that is com.learnwithiftecker.springboot REST API. Inside this package, currently we have only one class, Spring Boot REST API application. Let's open this. Collapse the sidebar. Here, this Spring Boot REST API application contains the main method, and from this main method, we are calling Spring application.run and providing Spring Boot REST API application.class. Now, let's start this project. Click on this play icon at the top to start this project. Let's click here. Let's expand the console and see what is in the console. It seems the project failed to start. Let's check the reason. That's right, application failed to start. Why? Failed to configure a data source. URL attribute is not specified. And no embedded data source could be configured. That is because, let's open our pom.xml. That is because here in the dependency, we have included the Spring Data JPA. So whenever we start the application, the Spring Data JPA is looking for the database configurations or the database. Till now, we have not set up our project to connect with the database, so Spring Boot is throwing this error. Let's configure our application to connect with the database. Let's close this pom.xml and this Java class. Opening the sidebar, from resources, open application.properties. Here, in this application.properties, I am going to provide the necessary configuration for connecting with the database. The first thing we need, that is the database URL. We can give this using spring.datasource.url. For MySQL, the URL is jdbc, then :mysql, :// then the server address. In my case, this is localhost. And the port, I'm running MySQL on my default port, so it is 3306, and then the schema name. I have already created a schema named productdb. Now provide a database username, spring.datasource.username. It is root, and provide the password, spring.datasource.password. This is, I'm providing my database password. Now we need to include the driver class name, spring.datasource.driver class name. I'm going to use the driver com.mysql.cj.jdbc.driver. Now let's provide some JPA and Hibernate related properties. Here I want to see the executed SQL in the console. For this, I'm providing this property, spring.jpa.showSQL, and set it to true. Then I'm going to provide a DDL auto, spring.jpa.hibernate and DDL auto. From here we have a couple of options: update, create drop, create, none, and validate. If you want to know more about these properties, check out my other video on Spring Data JPA crash course. For this project, I'm going to use this property, update. Then I want to see the executed query in properly formatted, spring.jpa, then provide the properties. Then we need Hibernate, format_SQL, set it to true. And finally, we need to provide a dialect, Spring JPA database platform. For MySQL, the database platform is org.hibernate.dialect.mysql dialect. Let's try to run the project. Click on this play icon to start the project. This time, the project started successfully. Here you can see in the console, Tomcat started on port 8080. Now, if you try to access the URL, let's open the Postman. Let's try to access the endpoint. Open a new tab. This is get request. Here, provide URL, localhost, port is, application is running on port 8080, and send a request. So our request does executed, but here we are getting this response, 404 not found. That is because we have not configured any endpoint to process this URL. Let's do this now. Back to the IDE. Minimize the console. Open the sidebar. In this root package, let's create a new package. For creating new package, I am using the shortcut, that is Command and N. We can also use right click, new, and then select the options from here. I'm going to create a new package and name it controller. So inside this controller package, I'm going to create a new Java class. The name of the controller is product controller. Let's collapse the sidebar. Here, annotate this controller with REST controller. This REST controller annotation makes the Spring know that this will be our REST resource. Then provide a request mapping. This request mapping annotation, provide the request mapping API /products. Any request comes to this endpoint will be processed from this product controller. Inside this product controller, add a get mapping, and here is a public method. It returns string and name it hello and return hello world. Now let's start the project again. Our project is started. Now in the Postman, let's try to access that endpoint. That was API, then products, and send a request. Here you can see we have this response from the controller. So our project is working. Now let's implement the REST API. Minimize the console, open the sidebar. Here in this base package, let's create necessary package that will be needed for our project. The first one is model. New package, name model. This model package will hold all the entity classes that is necessary for our application. Create another package, name it repository. We'll put all the necessary repository in this repository package. Then create another package, name this service. This service package will hold all the business logic. Now inside this model package, let's create our first entity. I will create a new Java class. Let's name it product. Okay, so this product class is going to be our JPA entity. To make this entity, right above the class declaration, I will add the entity annotation. And to be specific about the database table this class will map to, I will add the table annotation and give it a name products. With this table annotation, we are telling Spring Data JPA that product class corresponds to a products table in our database. Now let's define the fields of our product. Every product needs an identifier. So I will start with that. Private, long, ID. Next, the product name. This will be type string. Private, string, name. We will also want to include a description for each product. So another string field for that, private, string, description. And of course, we need to store the price. For this, double is a good choice. Private, double, price. Finally, let's add a field for the products category. Now, in more complex real-world application, you might create a separate category entity or perhaps use an enum. But to keep things straightforward, for this tutorial, a simple string will work perfectly fine for the category. Private, string, category. Here, my ID is showing an error. Let's hover over it and see what's up. It says, persistent entity product should have primary key. What does it mean? Every JPA entity needs a primary key to uniquely identify it. We have defined a couple of fields here, but we have not told which one among these will be our primary key. Here, I want this ID to be our primary key. To explicitly tell Spring Data JPA that this ID is our primary key, we need an annotation ID. And I want this ID to be auto-generated by the database. To achieve that, we'll add another annotation, generated value. You also need to specify the generation strategy. Since I am planning to use MySQL, which support auto-increment columns, the strategy we need here is this one, the generation type dot identity. Now, we need to add some constructor for our product class. JPA entities typically requires a no-args constructor. For generating a constructor, I am using a shortcut. In my Mac for IntelliJ IDEA, the shortcut is Command+N. If you are on Windows or using different setup, you can usually right-click inside the class, look for generate and select the constructor. It will bring up the generate menu, and for the first constructor, I will select none to create an empty no-args constructor. Next, we need another constructor. In this constructor, we will add every other field except this ID, because the ID will be generated automatically by the database. So back to the generate menu, constructor, and this time I am going to select all the field except this ID and click OK. And now we need to generate the getter and setter of this class. Generate getter and setter, select all the fields and click OK. OK. With our product entity nicely defined, the next crucial piece is the repository. The repository layer is what will actually handle all the communication with our database, fetching data, saving data, and so on. Let's create new repository for our product. In our repository package, create a new Java class, and this is important. We need to select interface, not class. I will name it product repository. Let me just collapse the sidebar here to give us a bit more screen. Here we go. Now, the magic of Spring Data JPA is that we don't have to write a lot of boilerplate code. This product repository interface will extend JPA repository. When we extend JPA repository, we need to provide it with two generic type parameters. The first one is the entity that this repository is going to manage. In our case, that's our product class. The second parameter is the data type of the primary key of our entity. In our product class, the ID field is of type long. And believe it or not, just by doing this, by extending JPA repository, our product repository now has the whole suite of standard CRUD operations available for our product entity right out of the box. It's incredibly powerful. If you are curious, you can actually navigate to the JPA repository interface. My IDE is asking to download source. Download it. Here you'll see that JPA repository itself extends other interface like this one, list CRUD repository. If we dig a little into this parent interface and even its parent CRUD repository, let's download the source. Here in the comment it says that this is the interface for generic CRUD operations on a repository for a specific type. Here you will find a whole list of predefined methods. For example, these save all. Then we have this find by ID, which is for retrieving an entity by its ID, and more. So by extending from the JPA repository, let me close those other tabs. So the main point is, by simply having our product repository extend JPA repository, we now have access to all these fundamental CRUD methods and even some more advanced Java specific ones without writing any implementation code for them ourselves. Now, these built-in methods are fantastic and cover a lot of common use cases. However, I need to query our data in more specific way. For example, I want to find all products that belong to a particular category. For situations like this, Spring Data JPA has a really powerful feature called query methods, sometimes referred to as derived queries. The idea is that we just need to define a method in our product repository interface following a specific naming convention. The Spring Data JPA will automatically understand what we are trying to do and generate the necessary database query for us. It's pretty magical. Let's try one. Suppose we want to find products by their category. Let me give a comment. We want to find product by category. Take a closer look of this requirement. What we want to do? We want to find. What we want to find? Product. Based on what criteria? By category. Let's define the method for this. Since a single category might contain multiple products, the return type for this method will be a list. A list of product. Now, for the method name itself, the convention usually starts with find. What we want to find? That is product. By what criteria? By category. I want to filter product by category. And of course, this method will need a parameter, the name of the category we are searching for. And that's literally it. We just declare the method. Spring Data JPA is smart enough to look at this method signature and figure out that we want to execute a query on the product entity. looking for records where the category field matches the value passed into this method. The whole mechanism of Spring Data JPA parsing method names to create queries is super handy. If you want to dive deeper, you can check my other tutorials specifically covering Spring Data JPA in more detail. I will make sure to put that link to the description below. Let's add another custom method. This time, we will find all products with price, that is less than or equal to a certain maximum amount. Again, this could return multiple products, so the return type will be list product. And for the method name, we can use find product by, then the field name price, and less than equal. This method will take a double representing the max price as its argument. Okay, let's do one more for good measure. Let's say we want to implement a search feature where user can find products by their name, but we want this search to be case insensitive, and we want to find names that contains a certain search term, not necessarily an exact match. The return type, you guessed it, will likely be a list of product. And for the method name, we can construct it like this: find product by product name, then keyword containing. This containing keyword tells Spring Data JPA to perform a like type of query. Then ignore case. This handles the case insensitivity. This method will take the name string as its argument. So there you have it, a few examples of how you can easily define custom query methods. These are all the custom queries I think we will need for this basic CRUD operation. Excellent. Our product repository is now well equipped with both standard CRUD operation and these useful custom finder methods. With our data access layer pretty much sorted, the next logical step is to build our business logic. For that, we'll introduce separate service layer in our application. Let's head over to the service package. Inside here, I'm going to create a new Java class and name it product service. Now, to tell Spring that this is a service component, we'll annotate it with service. Now, this product service will need to interact with our product repository to perform database operations. So, we need to inject an instance of product repository into this class. I prefer using constructor injection for this as it makes dependencies explicit and helps with testing. First, declare a private final field for our product repository. Product repository. And now, to inject it, we will generate a constructor. Again, on my Mac, I am using my ID shortcut, Command plus N. Then constructor, select the product repository field and click OK. Our constructor is ready and Spring will automatically inject the product repository bean when product service is created. Great. Now we can start defining the methods that will implement our business logic. First up, I'll create a method to get all products. This will be public method and it will return a list of product. Let's call it get all products. Inside this method, we'll use our injected product repository and call this find all method. Return product repository.find all. Now you might be thinking, wait, we did not define find all method in our product repository interface. And you are right. However, because our product repository extends JPA repository, which in turn extends interface like list CRUD repository, the find all method and many others are inherited and readily available for us to use. It's one of the great convenience of Spring Data JPA. Next, let's implement a method to retrieve a single product by its ID. This will also be public method. Now, when we fetch a product by ID, there is a chance that a product with the given ID might not exist in the database. To handle this gracefully, this method will return an optional. Make sure to import optional from Java util. This will be type of product. Name get product by ID and it will accept long ID as a parameter. Inside, we will return the result of product repository dot find by ID. Perfect. The optional clearly communicates that the result might be absent. Now, let's create method that utilize the custom finders we defined in our product repository. First, to get products by category. This will be public method, return a list of product, and we'll call it get products by category. It will take a string category name as a parameter. And here we'll call our custom repository method, return product repository dot find by category, and pass the category name. See how we are just calling the method we declared in the interface? Spring Data JPA handles the implementation. Next, let's add a method to get products with a price less than or equal to a specified maximum. Again, public list of products, and let's name it get products by price less than equal, and it takes a double price as input, and the implementation will call our other custom repository method, return product repository dot find by price less than equal, and provide the price. And one for searching products by name case insensitively and looking for names containing the search query. Public list of product, get products by name, it accepts string name. This will return product repository dot find by name containing ignore case and provide the name. So those are our main methods for querying and retrieving data. Now let's implement the method for creating, updating and deleting products. First, for saving products, which handles both creation of new products and update to existing ones. This will be public method that returns the save product object, which might include a generated ID if it's new product. Inside, we'll simply call product repository dot save and return this. The save method is smart enough to know whether to insert a new record or update an existing one based on whether the product's ID is present and matches an existing record. Finally, let's add method for deleting product. This will be a public void method as it does not need to return anything. Let's call it delete product and it will accept product. And the implementation will be product repository dot delete and provide the product. Okay, let me just clean up any unused import here. And there's our product service class. It now has the necessary business logic to manage our products using the products repository for data access. With the service layer in place, the next step in building our REST API is to implement the controller. The controller will handle incoming HTTP request, call the appropriate method in our product service, and then return the responses. Let's switch over to our product controller. This is where we'll handle the incoming HTTP request and use the service to perform the necessary CRUD operations. Alright, let's jump into our product controller. First thing, we need to get our product service injected in here so we can actually use it. I will declare a private final field for product service. And we'll use constructor injection. I will just use my ID to generate that constructor. Select the product service field, click OK. In this controller, we previously had a simple get mapping method named hello and just returned a hello world message. I'll change this so that when a request comes to the base endpoint, these API products, this method executes and returns all products from the database. First, I'll rename this method from hello to get all products and change the return type to list product. And in the return statement, we no longer need the hello world message. Instead, we will call product service dot get all products to fetch the products. Now, let's add another method for getting a specific product by its ID. This will also be a get mapping. The endpoint path needs a path variable for the ID. So we add quotation mark, then / curly braces ID. This ID inside these curly braces, this ID inside these curly braces tells Spring that it's a placeholder for the actual ID value in the URL. Let's define a public method. it should return a response entity wrapping a single product. Actually, on a second thought, let's refine the getAllProducts method first. It's better practice to use response entity here too, as it gives us more control over the HTTP response, like setting status code. So let's update its return type from list products to response entity and provide the list of product. And we need to adjust the return statement to use this. I will cut the service call. The return statement should be response entity.ok, and inside this ok method paste the product service dot get all products. This sets the HTTP status to 200 ok. Back to the method for getting an individual product. Let's name the method getProductById. To capture the ID from the path variable, we need the path variable annotation in the method signature. The type is long and we'll name the parameter ID. Inside the method, we'll use the product service to get the product. Let's store the result in a product variable. Product equals product service dot get product by ID and provide ID. Now, since getProductById returns an optional product, we must handle the case where the product is not found. We'll use or else throw. If the product is not found, this will throw a new runtime exception with the message product not found. If the product is found, the code continues and we return it within response entity.ok. Now let's create an endpoint for getting products by category. This will be a get mapping using the URL pattern /category / then the path variable category name. Here this category name is our path variable. Define the public method. It returns response entity of list of product. Let's call it get products by category. It accepts the category name using path variable. Let's put the parameter on the next line for readability. Path variable, it's a string named. This is the name of the variable. It's category name. Now for the return, let's call product service dot get products by category and provide the category name. This returns needs to be response entity. Let me cut that service call. The return should be response entity.ok, and inside ok we put the call to response service dot get products by category and another endpoint for filtering by price, getting products with price less than or equal to a maximum. The get mapping path will be price / then the path variable max price. This method returns response entity and the type is list of products. Get product by max price. It accepts max price via path variable. Again, placing the parameter on a new line, it's a double named max price. Inside we return response entity.ok, wrapping the call to product service dot get products by price less than equal and pass the max price. Okay, one more get endpoint. Searching for products by name. I will map this to the path /search. Its public method returning response entity of type list of product. Let's name it search product. Now for this search functionality, instead of using a path variable, I'm going to use request parameter, which is also commonly known as query parameter. So what's a request parameter? It's how you pass data in the URL after a question mark. For example, a client might call this endpoint like this. After this search, there may be a question mark, then name, then this equals some value. This part, after this question mark, this part is called query parameter. To capture this, we use the request param annotation. We accept a parameter named name of type string. For the return statement, we will use response entity dot OK. Inside, we need to call the appropriate service method. The get product by name is suitable here as it performs case insensitive search for names containing the query string and provide the query parameter here, that is name. That's our search endpoint using the request parameter. Now it's time to handle the creation of new product. When adding new product, the standard HTTP method is post. So this will be post mapping. Typically, a post request to the base collection URI is used to create a new resource. So we can just use post mapping without any additional path segment. Let's define a public method. It returns a response entity wrapping the created product. Returning the created product is good practice because the response can then include any server generated values like the product ID. Let's name this method create product. Now, to actually get the product details from the client for creation, they will usually send this information as a JSON object in the request body. Spring provides the request body annotation to capture this. We'll use this annotation with the method parameter of type product. Let's call this parameter product. Inside this method, the first step is to save this incoming product object using our product service. Let's create a new variable of type product to store the result. Once the product is successfully saved, it will likely have a new ID generated by the database. We should then return this new product in the response. For successful resource creation, the standard HTTP status code is 201 created. So we'll create a new response entity providing the new product and this HTTP status dot created status code. Make sure HTTP status is imported. Excellent. That handles creating new products. Now we'll do the update operation. For updating, we'll use put mapping. Define a public method. It returns response entity of type product. Name this update product. It accepts the updated data via request body product. Also, beside this request body, we also need to know the ID of the product which we are going to modify. So in the put mapping annotation, this will accept a path variable ID. And here in the update product method parameters, before the request body, will accept the path variable. The path variable is type long, name it ID. Inside the update product method, first we'll query the database to get the product by its ID. Create a new variable product. The name is product to update. This equals product service dot get product by ID and provide the ID here. If the product is not found, use or else throw to throw a new runtime exception with message product not found. If the product is found, we'll update it. We now have this product to update which holds the data from the database. We need to update the properties of this product to update object using the data we received in the product object from the request body. So product to update dot set name. This will be the name we received from the request body product dot get name. Then update another property product to update dot set description. This will be product dot get description. Then modify the price product to update dot set price. It is product dot get price. And finally the category product to update dot set category product dot get category. Finally call product service dot save product to update the product in the database. Pass the modified product to update as the parameter. Store the return data, the truly updated product, into a new product variable named updated product. And the return statement, create a new response entity, provide the updated product with the status code http status.ok. And the final task is deleting the product. This will be delete mapping. It accepts a path variable ID, the ID of the product we are going to delete. It's a public method, returns response entity. Name this method delete product. It accepts the path variable of type long, named ID. Inside this method, first we need to check if the product actually exists before trying to delete it. Let's copy the service call for fetching by ID from the previous method. This one. Copy and paste it here in our delete product method. Let's rename this variable to product to delete. Now we have the product to delete. We can call product service dot delete product and here provide the product to delete. And for the response in the return statement, I am just going to send a confirmation message. Response entity dot OK with the message product deleted. One more thing, here I made a mistake in this put mapping. I need to make sure the path variable is inside the quotes. And that's all for the product controller. Now let's start this project and check if everything works. Our project has started. Let's expand this console a little bit. Let's check what is in the console output. Here you can see logs indicating a new table products was created in the database with the column that we defined in our product entity. And this thanks to the Spring Data JPA handling the schema generation based on our entity definition. Let's check this table directly in the database. For checking MySQL table data, you can use any query tool like MySQL Workbench, which is very popular. But as I am using IntelliJ IDEA Ultimate Edition, this ID provides a built-in database tool that I can use. Using this handy database tool, I don't need a separate application. If you are using MySQL Workbench, you can check the data using that tool. For our case, here I am opening this database tool. Then I will click on this plus icon to add a new database connection. Then data source and select MySQL. Here we need to provide the necessary settings for the database connection. I have not changed any defaults for my local MySQL installation. So it's running on localhost and the default port 3306. Then I need to provide a username. My database username is root. I am providing the database password now. Let's test the connection to check if we are able to connect. Click on this test connection button. Yes, the database connection was successful. Click OK. You might not see the OK button here as this was outside my recording area. Here is our localhost database connection. If we expand this, it's not showing any schemas initially. Let's configure it to show our new schema. Check this box for product DB. Now it's visible. This is our product DB schema. Let's expand this. Under tables, we have this one table products. Let's expand this product table further. Here we see the columns ID, category, description, name and price. Those match the fields we defined in our entity. Now let's check the actual data in the product table. Double click on the table name. Let me just pull up this database tool view. Yes, currently we have not saved any data. So our product database table is empty as expected. Now let's add a new product. We'll test the API using Postman. Open Postman. Here open a new tab. First we'll check all the products endpoint. It will be get request. The URL is http localhost then port 8080/API/products. And if we send this request now, at this time we have this empty array in the response. This is because we have not saved any product data in the database yet. Let's add a product. Open a new tab in Postman. This request will be type post. For saving, the URL is same http localhost 8080/API/products. Navigate to body tab, select data type to raw, and from the drop down menu next to it, select JSON. Here, let's make Postman a little bit larger so that you can see the data clearly. Here, in the body, provide a JSON object. For name, let's say it's Laptop Pro. Then the description, it's high performance laptop with 16 gigs of RAM and 1 terabyte SSD. Give it a price, for example, $1299.99. And for the category, it will be electronics. Now send the request. Here we have this response. The status code is 201 created, and in the response body we have the product data for the laptop, and importantly it's now includes the ID which is 1. Now if we try to get all the products again, let's navigate to the previous get request tab. Now let's send this get request again. Now here you can see the response in an array containing one product, the product that we have just saved. If we check the database now, refresh the data, here we have this product saved in the database. Now let's add another item. In Postman, using the same post request tab, let's modify the product details. Set name to smartphone X. And for description, the latest smartphone. And the price is $899. And the category is electronics. Send the request. So our smartphone is saved with the ID 2. Let's add another product. This time let's say it's oven. For description, the best oven in the world. Let's say the price is $399 and the category is kitchen, and send a request. So we have another product saved in the database. Now if we send a request to get all the products, let's go to that get request tab, send this request. Here we can see we have this response JSON array with all of the products. We have all 3 products in the array. Now let's try to get a specific product. Now let's just find product by ID. We'll try to get this smartphone. The ID of this smartphone is 2. Open a new tab in Postman. Set the request to get. The URL is localhost 8080 API/products. And I want to get it by ID. So I will add the ID of the smartphone, which is 2, and send the request. Here we can see this product smartphone X with ID 2 is returned in the response. Now let's try to get a product by category. Let's try to get product from this electronics category. I'll copy the URL, open a new tab, paste it here, and update the URL. Update the URL to products/category, and then provide the name of the category, that is electronics, and send the request. Currently in our electronics category we have these 2 item returns, Laptop Pro and Smartphone X. Now if we query by another category, that is kitchen, and send, here we get this only one item, that is oven. Now let's search by name. I'll copy this URL again, open another tab, set it to get request, and paste the URL. And now we need to provide a query parameter. So after products, add a question mark and then the query parameter name. For the value smartphone X, here we don't need this quotation mark around the smartphone X in the URL parameter value, and send request. It's not working properly. It's showing all the data. Maybe I made a mistake. Let's check the controller. Open the product controller. This was our product controller. For querying by name, the endpoint mapping is /search. Okay, so here we need to update this URL in Postman. It should be products/search and then the query parameter, and send the request. and here we are getting this product by name. Now let's check other HTTP endpoints. For example, get products by maximum price. In Postman, let's update this URL. It will be price/maximum price. Let's say the maximum price is 500. Send the request. It's showing an error. Here I made a mistake in the URL. I provided a double / after products. I need to remove this one and send a request again. Here we have only one item, that is oven, whose price is $399 and that is less than 500. Now it's time to test the update operation. Let's say we want to update this item, this oven. We want to update the price and the ID of the oven is 3. Let's close other tabs in the Postman because it's causing some confusion. I just copied the data for the oven product from the previous response. Close every other tab, then open a new tab. For updating, it will be put request. The URL is localhost 8080 / API / products. Then we need to provide the ID of the product, that is 3. Navigate to the body tab, select row and JSON as the data type. Here paste the previously copied data. Here I am going to update its price. Let's say the new price is $599 and send the request. So in the response we have this updated data. Let's check this in the database. Refresh the table view. Here we have this kitchen product, oven, and the price is now updated to $599. And if we try to get this product by ID now to confirm via the API, let's back to the previous step. Update the URL to fetch the product with ID 3. Send a request. The response shows the data with the updated price. Now let's try to delete a product. Let's say we want to delete the product with ID 3, the oven. Open a new tab in Postman. This will be a delete request. The URL is localhost 8080 API products / then the ID of the product, that is 3, and send the request. And in the response we have this message, product deleted. If you check the data in the database, the row that contains the oven is now deleted. Now let's try to get all the data again in Postman. In a new tab, set it to a get request. The URL is localhost 8080 API products and send the request. And here in the response you can see we have only these 2 products. Products of kitchen category, that is oven, is deleted, and we have a fully functional REST API here. But I want to show you one more thing. I will try to add a new data to demonstrate something. Let's copy the JSON for a product from a previous response. Open a new tab in Postman. For adding a new product, it is a post request. For the URL, it was the URL saved in my Postman, that is API products. Moving the body tab and the data type, I am going to select row and then JSON from the drop down. Paste the copied data here. Let's create a new item here. For adding new item, I don't need this ID field, so let's remove this. And for the name, let's say it is laptop, and for the price, this time I'm going to provide a negative price and send the request. And see in the response we have this item created with a negative price minus $1299.99. So our API accepted a negative price, a critical flaw that could corrupt your data in a real application. Curious how to block such invalid inputs and make your API truly robust? In the next video, we'll dive into exactly that, implementing essential input validation. You won't want to miss it. See you there.